Have you ever looked up at the night sky and wondered if those tiny points of light are really just stars, or are they distant suns, each surrounded by worlds we may never see? What if I told you that every second you spend listening to this audiobook, you're hurtling through space at tens of thousands of kilometers per hour without feeling a thing? Right now, beneath your feet, an entire planet is spinning. Around you, invisible forces are holding galaxies together. Above you, ancient light that began its journey millions, even billions of years ago is quietly entering your eyes. The universe isn't simply bigger than you imagine. It's stranger, older, and more mysterious than almost anyone truly realizes. Hidden within its endless darkness are exploding stars, invisible matter, wandering planets, black holes that bend time itself, and mysteries that continue to challenge the greatest scientific minds on Earth. But this journey isn't just about learning fascinating facts. It's about changing the way you see reality itself. Because once you understand your place in the cosmos, you'll never look at the night sky the same way again. So settle in, keep your imagination wide open, and stay with me until the very end. Each chapter will reveal another breathtaking piece of a puzzle that stretches across billions of years and countless trillions of kilometers. This is Beyond the Stars, a journey through the greatest story ever told, the story of the universe itself. Long before there were planets, oceans, mountains, or even stars, there was a universe unlike anything we can imagine today. There were no galaxies decorating the darkness, no sunlight warming distant worlds, and no familiar atoms forming the matter around us. Everything that would eventually become every star, every planet, every living creature, and every human being existed in an unimaginably hot and dense state. Space itself was compressed beyond ordinary understanding. Then, in an event that forever changed reality, the universe began expanding. This wasn't an explosion into empty space. Space itself started stretching in every direction, carrying energy and matter with it. From that single beginning, time, space, and the physical laws that govern everything around us emerged together. As the universe expanded, it also cooled. During its earliest moments, temperatures were so extreme that matter couldn't exist in the stable forms we know today. Tiny particles collided continuously in a sea of unimaginable energy. Gradually, conditions became calm enough for the simplest building blocks of matter to form. Hydrogen and helium, the lightest elements in existence, became the first ingredients of the cosmic recipe. At first, the universe remained dark. There were no stars to shine and no planets to reflect their light. It was a vast, silent expanse, filled mostly with invisible clouds of gas drifting through the growing cosmos. Gravity, however, was already at work. Although it is the weakest of the fundamental forces over short distances, gravity becomes the dominant architect of the universe when enormous amounts of matter are involved. Tiny differences in the density of those early gas clouds slowly grew larger over millions of years. Regions containing slightly more matter attracted even more gas through gravity. Bit by bit, enormous clouds collapsed inward. As they did, pressure and temperature increased dramatically until the first stars ignited. For the first time, the universe was illuminated. Those first stars were unlike many of the stars we see today. They were often enormous, burning through their fuel at incredible rates. Inside their blazing cores, hydrogen atoms fused together under immense pressure, producing helium and releasing extraordinary amounts of energy. As these stars aged, they began creating heavier elements such as carbon, oxygen, silicon, and iron. These elements would later become the building blocks of planets, oceans, mountains, and eventually life itself. In a very real sense, every atom of calcium in your bones, every atom of iron in your blood, and every atom of oxygen you breathe was forged inside ancient stars that lived and died long before our solar system existed. When these giant stars reached the end of their lives, many ended in spectacular explosions known as supernovae. These explosions briefly outshone entire galaxies and scattered newly created elements across vast regions of space. The material expelled by countless generations of stars mixed together within enormous clouds of gas and dust. Over billions of years, these enriched clouds became the birthplace of new stars and new planetary systems. The universe constantly recycled its own material, turning the ashes of old stars into the foundations of entirely new worlds. Our own solar system was born from one such cloud roughly 4.6 billion years ago. As gravity pulled the cloud inward, most of its material gathered at the center, where pressure eventually ignited our sun. Around the young sun, the remaining gas, dust, and rocky fragments collided again and again. Tiny particles became pebbles. Pebbles became boulders. And over millions of years, these growing bodies merged into planets. Some became rocky worlds like Mercury, Venus, Earth, and Mars. Others gathered enormous amounts of gas, becoming the giant planets Jupiter and Saturn, while Uranus and Neptune formed farther from the Sun in the colder reaches of the solar system. Among all these worlds, Earth was extraordinary. It formed at just the right distance from the Sun for liquid water to exist over long periods. Its atmosphere evolved, its surface cooled, and its oceans slowly appeared. Deep beneath its surface, geological activity continuously reshaped the planet, while above, the moon stabilized Earth's rotation and influenced its tides. Countless events, each seemingly ordinary on a cosmic scale, combined to create a world capable of supporting life. Billions of years later, intelligent beings would stand on its surface, gaze toward the stars, and begin asking one of the oldest questions in human history. What else is out there? That question has driven exploration, inspired science, and fueled imagination for generations. Every telescope pointed toward the heavens, every robotic spacecraft launched into the darkness, and every astronaut who has left Earth's atmosphere represents humanity's desire to understand its place in the universe. Yet, the more we discover, the more we realize how much remains unknown. Every answer reveals new mysteries. Every discovery opens another door. And every journey beyond Earth reminds us that the universe is far larger, more complex, and more beautiful than we ever imagined. This is only the beginning of our journey. Ahead lie incredible worlds, violent cosmic phenomena, mysterious black holes, distant galaxies, invisible matter, and questions that scientists are still trying to answer today. As we travel beyond the stars, you'll discover that the universe isn't just a collection of planets and stars. It is a story billions of years in the making. A story that, against unimaginable odds, eventually led to you looking up at the night sky and wondering what lies beyond. As our understanding of the universe grows, one truth becomes impossible to ignore. Space is almost entirely empty. Movies often portray spacecraft weaving through crowded asteroid fields and planets sitting close together. But reality is far more astonishing. The distance between celestial objects is so vast that even light, the fastest thing in the universe, takes time to cross it. Light from the sun reaches Earth in about 8 minutes. That means every sunrise you witness is already 8 minutes old. When you look at Jupiter through a telescope, you're seeing it as it was tens of minutes ago. And when you observe distant galaxies, you're looking millions or even billions of years into the past. In astronomy, distance is more than separation. It is a journey through time. To understand the scale of our cosmic neighborhood, we must begin with the star that makes life on Earth possible, the sun. It appears ordinary because it is familiar, but in reality it is an enormous sphere of superheated plasma containing more than 99% of all the mass in our solar system. Every second, deep within its core, immense pressure forces hydrogen atoms to fuse into helium. This process releases an unimaginable amount of energy, flooding space with light and heat. Every plant that grows, every wind that blows, every ocean current that moves, and every meal we eat ultimately depends on the energy produced by this single star. Yet, despite its enormous size, the Sun is only one of hundreds of billions of stars in our galaxy. Even more remarkable, it is considered an average-sized star. Throughout the Milky Way exist stars far smaller than our Sun, and others so enormous that if one replaced it at the center of our solar system, its outer layers would stretch beyond the orbit of Mars or even Jupiter. Some stars burn for trillions of years, shining quietly through the ages. Others live fast, burn brilliantly, and die young in spectacular explosions that reshape entire regions of space. Orbiting the Sun are 8 major planets, each telling a completely different story. Closest to the Sun is Mercury, a rocky world scarred by countless impacts. With almost no atmosphere to protect it, temperatures swing from blistering heat during the day to freezing cold at night. A year on Mercury lasts only 88 Earth days, yet one of its days is longer than its year. It is a place where the familiar rules of daily life seem strangely reversed. Next comes Venus, often called Earth's twin because of its similar size. But appearances can be deceiving. Beneath its thick blanket of clouds lies one of the most hostile environments in the solar system. Its atmosphere traps heat so efficiently that the surface becomes hotter than Mercury's, despite being farther from the Sun. The pressure at its surface is crushing, and acidic clouds drift through its skies. Venus serves as a powerful reminder that even worlds that begin with similar ingredients can evolve into dramatically different places. Then there is Earth, our home, and so far the only known world where life exists. From space, it appears as a delicate blue sphere, wrapped in a thin atmosphere. That fragile layer of air, only a tiny fraction of Earth's size, shields every forest, every ocean, every city, and every living creature from the harsh environment of space. Astronauts often describe seeing Earth from orbit as a life-changing experience. National borders disappear. Conflicts become invisible. The planet appears not as a collection of countries, but as one shared home drifting through an endless sea of darkness. Beyond Earth lies Mars, a world that has captured human imagination for centuries. Rust-colored deserts stretch across its surface. Enormous volcanoes rise higher than any mountain on Earth, and canyons cut deeper than anything found on our planet. Evidence suggests that billions of years ago, liquid water once flowed across its landscape. Today, robotic explorers continue searching for clues that Mars may once have supported simple forms of life. If humans eventually establish settlements beyond Earth, Mars may become our first permanent home on another planet. Farther out, the solar system changes dramatically. Jupiter dominates this region like a giant guardian. More than twice as massive as all the other planets combined, this gas giant possesses storms that have raged for centuries. The most famous, known as the Great Red Spot, is so enormous that Earth itself could fit inside it. Jupiter's immense gravity influences the paths of countless asteroids and comets, sometimes protecting the inner planets by capturing or deflecting objects that might otherwise collide with them. Saturn follows, instantly recognizable because of its magnificent rings. Though they appear solid from a distance, the rings consist of countless pieces of ice and rock, ranging in size from tiny grains to massive boulders. Under sunlight, they shimmer like a vast cosmic jewel, making Saturn one of the most breathtaking sights in the solar system. Surrounding it are dozens of moons, some hiding oceans beneath thick shells of ice. These hidden seas have become some of the most intriguing places in the search for life beyond Earth. The journey continues to Uranus and Neptune, icy giants that orbit in the cold outer reaches of the solar system. Here, sunlight is so faint that noon resembles twilight on Earth. Powerful winds race through their atmospheres at extraordinary speeds, and mysterious weather systems continue to challenge scientists' understanding. These distant worlds remind us that our solar system is far more diverse than the rocky planets close to the Sun. Beyond Neptune lies a realm filled with icy bodies, dwarf planets, and ancient remnants left over from the formation of the solar system. These frozen objects preserve clues about the earliest chapters of our cosmic history. Every comet that occasionally visits the inner solar system carries material that has remained largely unchanged for billions of years, offering scientists a glimpse into the conditions that existed before Earth itself was fully formed. And yet, incredible as our solar system may seem, it is only a tiny island in a much larger cosmic ocean. Beyond the orbit of the outermost planets stretch the stars of the Milky Way, hundreds of billions of suns, countless unseen worlds, and distances so immense that even our fastest spacecraft would require tens of thousands of years to reach the nearest star. As our journey in beyond the stars continues, we will leave the familiar boundaries of our solar system and venture into the vast galaxy that has been our home for billions of years, a place filled with stellar nurseries, mysterious nebulae, ancient star clusters, and wonders beyond imagination. Leaving the solar system is one of the greatest challenges humanity has ever attempted. The immense distances involved are almost impossible to comprehend. The fastest spacecraft ever built would still require tens of thousands of years to reach even the nearest star if it traveled directly toward it. Space isn't just big, it is unimaginably vast. If the sun were shrunk to the size of a small orange, Earth would be no larger than the head of a pin, orbiting several meters away. On that same scale, the nearest star would be more than 1,000 kilometers away. Suddenly, the empty darkness between stars becomes the dominant feature of the universe. The stars that appear close together in our night sky are often separated by trillions of kilometers, connected only by the perspective from which we observe them. Our home among these stars is the Milky Way galaxy, an enormous spiral collection of stars, gas, dust, and mysterious invisible matter stretching roughly 100,000 light-years across. Imagine standing above it from unimaginable heights. You would see glowing spiral arms wrapped around a brilliant central bulge, slowly rotating through the darkness of space. Those beautiful spiral arms are not solid structures. They are regions where countless stars move together around the galactic center, each following its own orbit. Somewhere within one of these spiral arms, about halfway between the center and the edge, our solar system quietly circles the galaxy, completing one orbit approximately every 230 million years. Since dinosaurs first walked on Earth, our planet has traveled only a small fraction of one galactic year. The Milky Way contains hundreds of billions of stars, and around many of those stars are planets. Modern astronomy has revealed that planetary systems are not unusual. They appear to be common throughout the galaxy. Some planets are rocky like Earth. Others are giant worlds many times larger than Jupiter. There are planets with two suns rising in their skies, worlds where rain may consist of molten glass carried sideways by violent winds, and frozen planets drifting through space without orbiting any star at all. Each discovery reminds us that nature's imagination is greater than our own. Among the most beautiful structures in the galaxy are nebulae, vast clouds of gas and dust that stretch across dozens or even hundreds of light years. Some nebulae are the birthplaces of stars. Within these enormous clouds, gravity slowly gathers material into denser regions. As those regions collapse, pressure and temperature increase until new stars ignite, illuminating the surrounding gas with breathtaking colors. Although photographs often display vivid shades of red, blue, and green, These colors usually represent different gases and wavelengths captured through special filters. If a human observer could somehow safely stand nearby, the nebula would appear much dimmer because the light is spread across such enormous distances. Other nebulae tell a different story. Rather than marking the birth of stars, they represent their final farewell. When stars similar to our sun approach the ends of their lives, they gently shed their outer layers into space. Those glowing shells of gas expand for thousands of years before gradually blending back into the galaxy. The elements released during this process become part of future generations of stars and planets. The universe wastes almost nothing. It continuously recycles its own material, ensuring that every ending becomes the beginning of something new. Not all stars live peaceful lives. Some exist in pairs, orbiting one another in an elegant cosmic dance. Others gather in enormous star clusters containing hundreds of thousands of stars packed closely together. Within these crowded environments, gravity creates complex interactions that scientists continue studying today. Occasionally, stars pass close enough to influence each other's paths, exchanging energy like dancers changing partners in an endless celestial performance. Deep within the heart of the Milky Way lies one of its greatest mysteries, a supermassive black hole. Although black holes themselves emit no light, astronomers know one exists because of the way nearby stars race around an apparently empty point in space. The object hidden there contains the mass of millions of suns compressed into an incredibly small region. Its gravity dominates the central part of our galaxy, influencing the motion of stars that orbit around it. Despite popular imagination, this black hole is not pulling the entire galaxy inward like a cosmic vacuum cleaner. Gravity weakens with distance, and the stars of the Milky Way remain in stable orbits, just as Earth continues orbiting the Sun without falling into it. Black holes themselves are among the strangest objects in existence. They form when extremely massive stars exhaust their nuclear fuel and collapse under their own gravity. The collapse becomes so complete that a boundary known as the event horizon forms around the object. Beyond this boundary, gravity becomes so intense that nothing, not even light, can escape. To an outside observer, anything crossing the event horizon disappears forever. What happens beyond that point remains one of the greatest unanswered questions in modern physics. Yet, black holes are not simply destructive monsters consuming everything nearby. They also help shape galaxies, influence star formation, and challenge our understanding of space, time, and gravity. By studying them, scientists hope to uncover clues that may eventually unite the laws governing the largest structures in the universe with those describing the smallest particles of matter.